members of our committee meeting joining the call. And just to let you know who we are just a program that is committed to fostering and supporting women's engagement and equitable representation in high-performance computing and all the allied technology sectors. And as a program, we are dedicated to enhancing and supporting diversity, equity, and inclusion. And that's the reason why we're here. The members that we have so far right now are the University of Richmond, George Mason, VCU, Virginia Tech, William & Mary, Beams, Old Dominion, and the University of Virginia. We have a couple other universities in the region where we're still seeking members to participate and to become part of the committee. To give you an idea, when the program got started, I'll move to my next slide. We founded the program in April 2021, and we started doing this virtually just because of the nature of all the institutions that we are working with. It made it easier. So we are a total of 8 now, and we have a total of 323 members as part of our mailing list, which include everyone from all these institutions that I mentioned before, and also we have other members that are joined that are not in Virginia. The goal that we have is to support the inclusion of women and minorities in high-performance computing, and we want to create an environment that is inclusive of all. And of course, we welcome all allies to come and support the representation of women in HPC. That's all that I have for now. If you are interested in becoming a member of the Virginia Women in HPC, we have here our website. And we have also our QR code where you can actually visit our website directly. I am so happy and excited to always mention that we have our official logo that it says Virginia Women in HPC was actually designed through a competition with the students. And we went about selecting out of, I think that was 1 out of 5. And we are excited to have, something that represents all the institutions that have become partners of the Virginia Women in HPC. With that, Carson, I'll pass it to you and we can introduce our speaker today.
Gladys, I have a question. Can anyone, I don't live in Virginia, but can I join?
Anyone? Absolutely. Yeah. Anyone,
okay.
You don't have to be a Virginia person. Anyone that is interested in joining the program can. And just to give you heads up, right, we are in the business of becoming an official chapter of the Virginia Women in HPC organization, right? This is an international organization, and just we had the opportunity to apply and become one of the chapters.
Great. Thank you so much, Gladys, for introducing the program. And with that, I'm Karsten Siller with Research Computing at the University of Virginia. I am very delighted to see so many of you here today. And as I mentioned, if you can, please turn on your camera. It's nice to be able to put faces to names, so thank you for that. So today, as part of our Virginia Women in HPC Leadership Journey series, I am very excited to introduce today's speaker, Dr. Neena Imam. Neena has had quite an illustrious career. She earned a PhD in electrical engineering from Georgia Tech and has been engaged in research and computing in a large variety of different roles. For example, she was a science fellow to Senator Lamar Alexander. She was also a research scientist and later deputy director of research collaboration, computing, and computational sciences at Oak Ridge National Laboratory. For those of you who are working in the high-performance computing domain, probably know that Oak Ridge is the home of the world's fastest supercomputer called Frontier. So a lot of large-scale and now even exascale computing going on there, and I'm sure Neena could tell you more about that part as well. So more recently, Neena jumped into the private sector, and she is currently the director for research engagement at NVIDIA for the Americas region. And so again, we are very excited to have you here, Neena, and to hear your career story with maybe highlights of successes and perhaps some challenges that you experienced. And so Neena will start us off, and we will follow up with a free-flowing Q&A session. So for the audience, I would like everyone to please mute your microphones and post your questions in the chat, and I will call you up later on those questions. So without further ado, please, Neena, go ahead.
Thank you, Kirsten, for the great introduction, and I'm delighted to be here. I do have a couple of slides that I want to share, just about my feelings as to where the HPC, AI, and in general, the computing ecosystem is going, but those are only a few slides. We want this to be a free-flowing question and discussion session, and I really like that particular format. I will just show a few slides, and after that I will stop talking and we can have a discussion. So I am having some bandwidth issues as I'm working from home, so let's see if I can pull up my slides here, and we can start sharing. Bear with me, share screen. I was just doing that a minute ago, right? Okay. I believe everyone can see my screen now, correct?
Yes, we can.
Okay. So this is really about leadership journey and what motivated me to go through the career journey that I have gone through, right? And my challenges and the things that I loved and the things that I did not like so much. So maybe I can just say a few things about myself beyond what Kirsten mentioned in his very generous introduction. Yes, I'm an electrical engineer by training, and my PhD in electrical engineering is from Georgia Tech, and my PhD thesis was on quantum optics, quantum computing. Back then, we really didn't talk about quantum computing that much, but it was quantum devices, but very strong computational background. Before that, my master's was from Case Western Reserve University in Ohio. And my master was also in electrical engineering. My bachelor's in electrical engineering as well is from California Institute of Technology. So I have, moved around the country. Why did I start studying electrical engineering? Because I was always motivated by science. For me, science and education, those were always a silver bullet to give me the freedom to learn about cutting edge technology and learn about the world in general. So that is why I started pursuing my studies when I was an undergrad. And even when I was in undergrad, I knew that I was going to get advanced degrees because that was my passion, learning. And I'm not suggesting that getting advanced degrees is it's a career path that everyone should follow, but it certainly enabled me to follow my passion. I was always interested as well in cross-disciplinary research and learning about new things. And if you look at my career highlights and some of that Kirsten mentioned, you will see that I have done different things, which actually gave me a broad perspective, not just about science and technology, but also science policy. And right after I got out of grad school, I started working at Oak Ridge National Lab. And as Kirsten mentioned, that Oak Ridge National Lab is the home to the world's largest, fastest supercomputer right now, which is Frontier. I started as a postdoc, and I worked my way up, and I was there for 20 years. So being in a national lab for 20 years means that you are, getting to do fun stuff, right? I mean, I would say that national labs has national labs. There are 17 Department of Energy national labs in the United States. Now, these national labs, they occupy a very unique position in the R&D ecosystem. Foundational work is done in universities, as you know, and then product engineering, product development that happens in industry. And right in the middle are the DOE national labs or other national lab types of enterprises, because they have the infrastructure that cannot be replicated in either in academia or in industry. For example, the large particle accelerators, Fermi National Lab, SLAC, Oak Ridge National Labs Leadership Computing Facility. These are national assets, right? And these are these big DOE assets are there to serve and enable the national mission, the United States national mission. And as a result of that, national lab scientists work on very different type of problems. They cannot compete with academia nor with industry. They have to enable problems that that fits into the mission of U.S. Department of Energy. And as a result of that, I had a chance to work on many different things, many different projects, cutting edge technologies, worked with many different sponsors, DOE, DOD, and other intelligence community and all of that. And I was also able to develop very close collaboration with industries such as NVIDIA, my current employer. Because, as you know, NVIDIA is, of course, the powerhouse of AI and GPU computing, but it is also an HPC vendor, right? Because, and I will show you in the next slide that some of the biggest supercomputers in the world, for example, the Summit supercomputer at Oak Ridge National Lab has NVIDIA GPUs. NVIDIA itself has a supercomputer that is actually amongst the top 10 in the top 500 list. And if you don't know what the top 500 list is, I will tell you shortly. And so as a result of that, I had very close collaboration with NVIDIA. I worked on joint projects with NVIDIA before I joined NVIDIA. And after 20 years or so, I said, well, maybe I should go and get some industry experience, learn about the latest in AI, and who better than NVIDIA, right? And I do not mean this to be a sales pitch for NVIDIA, but I'm just sharing what motivated me. And then I joined NVIDIA a year and a half ago, and currently learning, I consider myself a lifelong learner, learning about AI, GPU accelerated computing, as well as HPC. And my current role is the Director of Strategic Researcher Engagement in North and Latin Americas. What does that mean? That means that I work with researchers that are developing GPU accelerated computing as well as AI and machine learning, and enable them to solve their problem in a more high performant way. So as during this process, my team engages with academic researchers, not just academic researchers, but also, other nonprofits, and really, roll up their sleeves and enable technology adoption. NVIDIA has many different types of SDKs and software framework that can actually help researchers solve their applications and their problems in a better way, high-performant way, and that's where my team comes in. Now, let me come to my next point. This particular seminar or this particular event is about HPC. Why am I talking about AI and machine learning and all of that, right? So I am saying that because the nature of HPC has changed. HPC is just not, and that brings me to my next slide. The computing ecosystem is changing. HPC just no longer means, that it is floating point operations per second. HPC is now defined. I would say that just in terms of floating point operations, but also in its ability to process huge amounts of data. And I will say that the best supercomputers in the world are also the best AI supercomputers. So all of these, there's a convergence of HPC and AI and also beyond more computing. And we'll talk about that a little bit more. I certainly do not mean for this discussion to be, a seminar that is where, I'm just talking about technology, but I just want to give you a background of my perspective on what excites me about HPC, because this is such an exciting time to be in the computing ecosystem in general, whether you're doing HPC, whether you're doing beyond more computing, or whether you are doing AI machine learning. And what is the latest in HPC? As Kirsten mentioned, the exascale supercomputer is already here. So what is next? Is that a race towards zetascale supercomputing? Maybe, maybe not. But we'll find out. We are not there yet. And the other thing is the rise of hybrid architecture. When I say hybrid architecture, I mean that these HPCs, most of the HPCs now also have a CPU as well as an accelerator, where you can offload certain parts of your workflow, such as a GPU, for example. And that's where a GPU companies such as NVIDIA comes in. Computing ecosystem is also becoming more distributed. We are dealing with Internet of Things. We are trying to connect the sensor data signals in autonomous driving, or drone signals, or from perhaps from operating room somewhere, where you have embedded real-time data that has to be processed. So we are trying to deal with all of these edge systems and connect that and stage this particular computing paradigm from the edge to the cloud to the data center, as well as all the way to an exascale supercomputer, for example. Then, of course, there's artificial intelligence, which is very pervasive. And as you all know, that feature of data analytics and data processing already does include AI, and HPC workflows all include AI, or at least going in that direction. And that is going to become more and more common in the future. And also, of course, there's a plateauing of Moore's law, right? And so what is post-Moore computing? Is that quantum? Quantum is the buzzword. Everyone is hearing about that, talking about that. Maybe, maybe not. There is, of course, the issue of energy efficiency and sustainability. Because HPC, these supercomputers, they consume large amounts of power. For example, the largest supercomputer in the world consumes upwards of 20 megawatts of power, right? But this is after very careful design, infrastructure design, application, and hardware co-design to ensure that everything is working in a synergistic manner. But we need to pay more attention to this. And I'll just throw up a slide here about HPC. This is the pre-exascale and exascale U.S. landscape. This is, just in the U.S. There are, of course, other systems elsewhere, but as I mentioned, that you guys can go and look at the top 500 list, right? It's on Wikipedia. So for those that don't know what top 500 list is, it's a ranking of the biggest supercomputers in the world. Everyone, all these different HPC, I will say supercomputers here, because HPC, not all HPC platform is a supercomputer, right? So it happens twice a year, in June at International Supercomputing and in November at the Supercomputing Conference. The different entities will submit their benchmarking numbers. They will use there are different types of benchmarks like high performance LINPACK, other types of benchmarks are there, and they get ranked, and then it's that ranking gets updated twice every year, and this is a big deal in the HPC world. And I will say that Frontier is the biggest supercomputer in the world right now at Oak Ridge National Lab. I was fortunate enough to see the installation of at least part of, when there was it takes a long time to set these machines up. So I was there for part of the time. It is, and the peak performance is indicated here in terms of petaflops, so 10 to the power 15, but these are exascale machines. As you can see, the exascale machine currently, the first one in the world, the open science, we don't know what's happening in the classified world, or even if we knew, we couldn't talk about it. It is not quite 2 exaflops, right? And before that, Oak Ridge also had the Summit supercomputer. Summit also has NVIDIA GPUs, and it is actually still amongst the top 10 in the latest top 500 ranking. I forget exactly which one, maybe 5, 6, but it is both Frontier and Summit at Oak Ridge are amongst the top 10 in the world right now, as well as NVIDIA's Selene supercomputer. It is not, it is number 9 currently in the top 500 list. It was built with NVIDIA's Ampere GPUs, 63 petaflops on high performance LINPACK. So it gives you an idea about these types of big machines and what kind of work they're capable of, what kind of work do they do. They do all sorts of work, and I'll just talk about that a little bit. I'm just going to go through, maybe I don't have that particular slide here, and I really want to stop talking, using slides, because I want to have a discussion session. But, exascale supercomputer, what they do, very large scale problems, right? But as I mentioned, that things are changing, the computing ecosystem is changing, and there are massive opportunities in leveraging AI. And that's what I'm loving at NVIDIA, learning about AI and the convergence of AI and HPC's traditional high-performance computing, data-driven simulations such as digital twins, and which is an emerging area, Department of Energy National Labs, the research ecosystem, as well as NVIDIA is thinking about how to make digital twins more performant, because data-driven simulations really enables you to do things that you cannot do with traditional modeling and simulation. Okay, maybe I'll just talk about one more slide, and then I'll stop talking and we can have a Q&A. And I will say that AI, large language model, generative AI, those are, merging with high performance computing, because as you know, the Gordon Bell Prize, which is, some say that's the Nobel Prize of in the computing world, the one at SC22, was on large-scale language model, generative AI, and the University of Chicago, Argonne National Lab, NVIDIA, and other partners worked together to come up with a generative AI model that talks about the COVID virus's dynamics. So this tells you how HPC and AI are merging together. And let me just say a little bit about AI for social impact, because NVIDIA is a powerhouse of AI, and it's in every industry. You know, it's in consumer internet, financial services, healthcare, retail. And I talked about, you know, in healthcare, I just showed you the Gordon Bell for the last year's Gordon Bell, but it was also a winner for Gordon Bell AI-enabled health sciences. Also won the Gordon Bell Prize in 2019. And that was also run on a supercomputer. So,
Neena, we have a couple questions in the chat. The first one is about from Grace. So please feel free to unmute yourself, Grace, and ask about the top 500 ranking.
Sure. Thanks, Karsten. Thank you, Neena, for all the interesting information. I was just curious if the top 500 ranking is entirely just about speed and scale, rather than, you know, also accounting for energy efficiency. I guess because, you know, it's one thing to be the fastest, but it's not the best thing if you're the fastest that burns the most energy.
You're absolutely right. Top 500 is about speed and scale, but there are other benchmarks that are used. There's Green 500 that is about that ranks supercomputers based on their energy efficiency. So some of these supercomputers that I just showed on top 500, they also do pretty well on Green 500. I don't remember that, but you can just look on, you know, do a Google search on Green 500 list. There's also something called Graph 500. So, you know, so there are all different types of ranking.
Thank you, Neena. Another question from Eric about cloud computing.
Thanks, Karsten. Yeah, I was just curious what you thought personally about whether cloud is going to, you know, the share of cloud resources used in HPC will continue to grow, and if so, do you envision a lot of less on-premises computing over the next few years?
Yes, I believe that cloud computing is going to become more and more prevalent, because the reason for that is that not everyone, because the HPC is an expensive endeavor in terms of dollar amounts, right? And we have to democratize the access to HPC as well as AI. So cloud computing is becoming more and more commonplace. And at NVIDIA, there is also a big push in terms of making our SDKs and our software frameworks available via cloud. We have something called NGC, which is our cloud. That one, if you join the developer programs, you will have access to that. But to answer your questions, yes, I do see emerging. This is a trend that's going to happen more and more in the near future. So, you know, some of these, being at Oak Ridge National Lab, the cloud computing, container technologies, these were really not talked about that much 10 years ago when I was there, right? But then recently, there's a big push in, putting together, installing containers, Dockers, OpenShifter, this kind of container virtual environment in HPC, in these bigger supercomputers as well, to enable easier access to this technology.
Thank you. And I think there's another question. Mandy, please go ahead.
Hi. You mentioned that NVIDIA is working on digital twins, and we use digital twins to do epidemic modeling and to recommend placement of charging stations and so on. I was just curious, what kind of work is NVIDIA doing with digital twins, and what kind of applications are they exploring?
Right, and I can tell you a little bit more about that, but remember though that this is not meant to be a technical talk, but the SDK, the software development toolkit that we have for digital twins at NVIDIA is Omniverse. And I think it does, yeah, and we are working with different industry as well as research organizations for them to develop digital twins within the Omniverse environment. For example, Amazon has used NVIDIA technology to develop digital twins of their warehouse. So that is one application. There are other applications as well. I will just put the name of this particular SDK in the chat. And any follow-up question, I think Kristen can connect you to the Omniverse product team. And she's online as an NVIDIA representative.
Yeah, thanks, Neena. I'm taking note of the questions, and I will follow back up with some more info on that.
There you go. So it's called Omniverse, and also a lot of this information is available on NVIDIA website. So you can go and look up some Omniverse, some preliminary information.
Okay, thanks.
Thank you, Neena, and thank you for all the questions. So we had some question about the technical side. I do want to switch gears a little bit, but to come to the leadership and DI.
I will stop sharing then, yes.
But if you have other slides to share, that would be
No, I think, this is good. I mean, I showed what my vision and what I think, what everyone, most people would agree, the trend in the computing ecosystem, which is the convergence of multiple technologies. So I believe I've shared enough about that.
So thank you. Maybe I start with one question. Clearly, you have had tremendous success in your career in various roles. And I'm curious, so in your experience, what specific DEI programs or events are there that really create opportunities in leadership for women and minorities in the IT industry in particular? Maybe you can look from the NVIDIA point of view specifically.
Okay, so I think at NVIDIA there is tremendous opportunity for career growth. NVIDIA, for example, give you a specific career growth for women as well as for everyone. To give you an example, NVIDIA has a very, very flexible working from home or working from office, those kind of policies. So if someone is to work from home, that is also encouraged. Cultural diversity is encouraged. I work with a team that are distributed all over the world and comes from all types of cultural background. My team NVIDIA employees come from all types of cultural background, as well as geographical background, ethnic background, religious background. So very, very diverse workforce, I would say. And with that, of course, comes with challenges. How do you train your leaders to become more, to be able to deal with a diverse team, and how do you maintain a good and cohesive team and that are respectful for everyone? So there are certain leadership trainings that we go through to enable for the leaders' sensitivity, as well as advancement opportunities for everyone. For example, there is NVIDIA participates in Grace Hopper conference, which is a conference for mostly female scientists, and there are other types of opportunities like that. I myself participate in I have participated in Grace Hopper. I have spoken at Grace Hopper. I speak in multiple events such as this. I am a member of IEEE as well as ACM, where I am also part of the IEEE mentor program that, and I spend a lot of time mentoring and working with minority groups.
Thank you. Follow-up questions in the audience?
Yes, Kirsten, I have a question. And my question for you, Neena, would be, we have a diverse group here. We have faculty, we have staff, we have students. But my question for you is, if you can address the students in terms of, you have basically give us an idea, what is your vision, where do you see this component of HPC and AI moving forward. But if you had to, give the students an advice that are just beginning to explore this, world of HPC, where would you tell them to start looking or heading, to try to see the big picture where their careers can actually take off?
Right, of course. So, this is a very good question, right? Because I think we all have to become we all have to be able to be comfortable in interdisciplinary collaboration. And I think that has enabled me to work on many different fields because I always wanted to learn about different things. So as I said, that my journey at NVIDIA started from my collaboration with NVIDIA while I was at Oak Ridge National Lab. So I worked from, HPC networking to beyond more technologies to AI and machine learning. So that entire spectrum. And this entire spectrum is just not about traditional HPC workflow. It is about, it's more and more about integrating AI in HPC workflows, more and more about integrating data science in your workflow. It is more and more about beyond more computing. And I believe that in the near future, there is big push about integrating a quantum processor or quantum technologies as not to replace traditional HPC, but as a tool to enable speeding up of certain workflows that are applicable only for that type of architectures, because DOE is making a big push about that. NVIDIA has a lot of quantum technologies. NVIDIA does not make quantum computers or qubits, but it does have a lot of technologies to support in the development of this emerging computing paradigms. So I think students need to be aware of what these different paradigms are.
Excellent. Thank you, Neena.
Other questions? Anyone?
There is a question, Karsten.
Oh, sorry. Anshu, please go ahead.
Oh, sure. Thank you. Sorry for my awkward position. I'm in the kitchen right now. I just finished up lunch. Thank you, Neena, for your excellent presentation. I was just wondering, you mentioned quantum computing. It's like that's one of the topics I'm interested in. With regards to quantum computing, do you have any idea of how specific they might be integrated into HPC? Do you envision more quantum processors or like more quantum networks to link like different quantum computers to different HPCs or anything else?
Of course, very good question, right? So right now, the quantum computing world is limited by the availability of hardware that scales up. But there's big research effort from industry, academia, as well as national labs to develop those test beds or this large-scale quantum computing hardware. But we are not there yet. There's also, but I believe that in the near-term trend in this field is a hybrid architecture where a quantum processor acts as an accelerator for HPC platform. And we are seeing some of that already happening. And the software framework that NVIDIA is developing is also takes that into account. Now, quantum networks, that's a different story. Of course, you know what, as you rightly mentioned, that quantum network is needed to connect quantum computers as you'd connect different types of computing technology for information sharing and scaling up the computing, right? Quantum networks are people, all the different agencies, federal agencies are talking about it. And there is some very preliminary work that has been done, but quantum networks, you know, it's very different from quantum computing, not quantum computing, but very different from traditional networks, because quantum information cannot be copied, as you know, right? So, so how do we go about that? I will tell you that I was at a panel for on quantum networks at ICCN in Hawaii, where DARPA program manager as well as NSF program managers talked about the research projects that they want to fund in quantum networks, right? So this is obviously something is paying attention to, because this has to happen in order to scale up quantum computing, but it's a very difficult problem.
Thank you for your excellent response. That was very useful.
Great. Thank you. Other questions in the audience? As I mentioned, please put them also in the chat if you can.
So, Karsten, I had a question. So, Neena, if we were given a bucket of money to spend on systems or resources over the next 5 years, where do you recommend we should invest this money?
Well, I would certainly say in, you know, one of the, well, if you could write your own check, right? Wouldn't that be wonderful? Of course, in workforce development, right? That's a major key, because there is need for the new generation of computer scientists or HPC scientists that can actually work in this interdisciplinary fields. So certainly in workforce development, certainly in making these resources available to minorities and disadvantaged groups. I mean, a university may have a supercomputer or an NVIDIA DGX superpod sitting around, but does everyone have access to that? It is actually not as simple as it sounds, right? Because you also have to support the scientists that are, you know, consuming all the nodes and running big, you know, for example, quantum chemistry problem or something like that, but as well as other scientists that are using or students that want to have a smaller problem, but they can benefit from the HPC resources. So there's different types of platforms that you need to stand up. So enabling that would be something useful in terms of technology. I think certainly interdisciplinary research, the incorporation of AI and machine learning in HPC workflows. I mean, it's a very active area of research because I mean, many of the problems are unsolved, and there's many opportunities to contribute. So I would say, what is the best way to incorporate AI and machine learning in traditional HPC workflows, and benchmarking those? I think that is somewhere where one should also invest.
Thank you.
Thank you, Neena. I think we have time for maybe one more brief question and brief answer, and then we'll want to start wrapping it up. So who wants to take the last one? Everyone is thinking hard. Maybe I just want to maybe close out with one question. What do you think, what kind of actionable steps can we as a community members take to individually to really contribute to diversity and equity in this kind of profession?
Well, certainly workforce development is absolutely important. So I think mentorship is a good thing. I was born in a third world country, and I had tremendous mentors that enabled me to achieve some of the things that I wanted to. I mean, I have a long way to go, right? But I had fantastic mentors in graduate school. I had fantastic mentors at Oak Ridge National Lab, and I have great mentors at NVIDIA. So if we could all spend some time, this and set aside some time from our very busy schedule in mentoring students and certainly drive home the value of diversity in any type of scientific enterprise, because it is just not about diversity of demographics, race, ethnicity. Those are all very important, but for a team to thrive, to have good technical and research output, you also need diversity of functionality that comes from, you for example, if you're looking around in your team and you see that, hey, everyone is an engineer. Well, I mean, that's maybe not a good thing, because then you are in an echo chamber. You need diversity of perspective, diversity of technical background. That's where cross-disciplinary research comes into play as well. So we have to understand that diversity has many different dimensions, and to first of all, to educate ourselves about the different dimensionalities, all the different dimensions of diversity, and then spending time mentoring the future workforce, so that those philosophies are integrated in them, is ingrained in them as they make their way into the workforce. I think that's what we should do.
Thank you so much. I think those are very great closing remarks. First of all, I'd like to thank you, Neena, for a wonderful presentation, for making the time, really being a role model there as you kind of, mentor others. And also I'd like to acknowledge Kristen Slater for being here, for really establishing the connection with us here, so we can actually host this event. And so with that, I think, is Heather on the call? I think we have her.
Karsten, can you hear me?
Yep, I can hear you. Announcing our next event.
Yeah, thanks. So our next event will be on Tuesday, October 31st, so Halloween, and we'll be hosting about 10 to 12 students to present lightning talks about their research. So each student speaker will have about 3 minutes and 1 to 2 slides to showcase their research. Students, this is a really great opportunity to boost your presentation skills and share your research with a pretty diverse audience. Please sign up by September 29th for consideration, and we'll select participants by October 17th. And prizes will be awarded to the best student talk. I'm going to post the link to the registration in the chat, and then we will send out the link to register for the actual event soon.
Thank you very much, Heather. Again, thank you, Neena, for joining us today. Thank you, Kristen, and everyone in the audience. Thank you to the other members of the Virginia Women HPC Committee for helping organize this event. And hopefully you take some interesting information back home, or if you're at home, think about it, and we'll hope to see you at our next event. So thank you very much.
Thank you.
Thank you. Thank you for inviting me. I really enjoyed the discussion, and I will join the organization. So
Thank you so much, Neena.
appreciate it.
Fantastic.
Just one last thing for the students that are here at UVA. I just want to quickly announce, I'm probably going to share this in the mailing list, but we just open opportunities to hire student workers with research computing. So any of you that are interested in learning more about HPC and that you are at UVA, please feel free to reach out to me. We will begin the process shortly, looking for all the 5 candidates. Thank you, Carson.
Thank you very much.
We stop the recording.